Hi everyone, my name is Ryan. Today I am going to demonstrate the features of our tool called CI-Bench. CI-Bench is a framework which aims to evaluate the LLM-based program repair tool on real-world CI failure data. So we actually chose Bugswarm, it's quite popular software defect dataset as our real-world CI failure data. Bugswarm is constructed by mining through consecutive failed pass job pairs of a particular repository, and then it is containerized into a Docker image. So this Bugswarm Docker image have a fixed version of repository and a failed version of repository, and which we call the Bugswarm image as an artifact. So our goal is to, using the framework CI bench, we will use a LLM based program repair tool and fix the build failure of that particular failed version of the Bugswarm artifact. So currently we are only supporting automated code repair in our CI bench framework, and we actually are using three LLM tools: SUI agent, agentless, and autocode rover. So today my demonstration, I will show how we can use SUI agent through our CI bench framework to fix a particular Bugswarm artifact. So these are the prerequisites which are installed in my PC, and before going through the details, we have to actually create a YML file for each tool to demonstrate what we will do. So basically, we have to create YML file for each tool, and how we can actually create the YML file, we have to go through the README of the particular tool. So if we go to the README of SUI agent, so we can see there are lots of commands and the LLM to go through. These are the setup commands, and this is the run command by which SUI agent is run. So if we notice that from the run command, we can find out some parameters which we will use in the YML file. So this is a parameter, LLM model, the image tag is a parameter, the config file is a parameter, the cost limit is a parameter. So if we go to the YML file, so this is the YML file actually. So we have set all the parameters we have actually discussed, and we will use GPT-4 for this particular task, and we'll have to set up the tokens. So this is the Bugswarm token which we will use to collect the CI failure data. We can use OpenAI token, Anthropic token, and user will choose whatever LLM API they will use, and they have to set up the virtual environment name. Why we need the virtual environment name? Because our framework actually sets up the tool at first, then run the tool on a particular Bugswarm artifact. So the setup command can be, we can choose one of the setup commands. It might be Conda or it might be Python virtual environment. And the run command, we have to put the run command from the README of SUI agent. So let's go to the, yeah, so then we go to the setup the tool. So for setting up the tool, we will use this command. So this command have some options such as task, tool name, and virtual environment. So right now we are actually targeting code repair task. So it will be repair. Tool name, we are actually using SUI agent. So tool will be replaced by SUI agent. And the environment option, we will use Python or Conda. So we can use one of them. So this is the command. So right now we will put all those parameters. So it's virtual environment, we have to use Python. So yeah, so basically it starts installing all those things and the setup is going on. So we are done with the setup. So we are done with the setup. Now we will actually run SUI agent through our framework on a Bugswarm artifact. So we will use this this command. So task is just like before, it's a code repair task, so it will be repair. Tool name will be SUI agent. Virtual environment, we have used Python virtual environment, so it's Python. And the artifact ID, we will actually target an artifact, TensorNav tracker 647832123. So it is basically what SUI agent will do. It will try to fix the failed version of this artifact. So before going through that, we need to see what is the root of the cause of the failure of this artifact. So I have actually downloaded it through Buxom token. So we can see that there is a build failure. Why there is a build failure? Because there is a null point exception on that particular function decode on Kestrel protocol decoder file. And that's why a test case has been failed. There is an error, so that's why bit failure occurred. So we will actually try to fix it using SUI agent. So the run has been started. So we have to actually wait for some time. So the run has been finished. We can see that a patch has been generated. So that null for the null pointer exception, they have put a null check over there. So that's why actually causes the build success of the particular build. So we can actually test in hand how and so let's go to the readme. So there is a command. So there is a command. This is the executor, and we have to give it as a patch file path and the artifact ID. So we will test whether the patch is correct or not. I have put the patch file location and the artifact ID over there. So let's find out. Yeah, so the patch is successful. We have seen that the build has been successful. So yeah, there is no failure, no error. What we have seen in the fail log, there is a null pointer exception and there is an error. So the LLM tool generated patch, SUI agent generated patch actually fix the issue. So our framework has another feature. So we have seen that how to run a single artifact. We can run multiple artifacts as well using this feature. So using this feature, okay. So to allow multiple artifacts, we have to put the artifacts into a file such as like this. So this is the list of artifact separated by enter, uh, and the command is really simple, just like the single one. So the options are pretty similar, just the last option will be the file. So if we start running this, so if we run this thing, sorry, I have made a mistake. So this will be the task. Yeah, it started running. So this is how we can actually use our tool to fix one artifact or multiple artifacts. Thank you.